Hi, this video is going to guide you through how to determine where rational expressions are undefined. But before we go over that, we have to talk about what a rational expression is. A rational expression is just a fraction formed by polynomials. Basically, if you have a fraction and it has a variable in the numerator or denominator, it's a rational expression. And all these examples that you're going to see today in the video are rational expressions. Now, a fraction, or a rational expression, is undefined when the denominator equals 0. We know that. Now, certain values of x are going to lead our rational expressions to have a 0 in the denominator. And we never want a 0 to be in the denominator. So all of these x values that cause a 0, we call excluded values. We leave them out of our expressions. So let's find the values that make the expressions undefined. We're finding those excluded values that we don't want. When you're talking about something being undefined, you're always going to take the denominator and set it equal to 0, because undefined is just when the denominator is 0. We don't care about the numerator. You could really just cross it out for all I care. You're going to take x minus 2 equals 0, and you're going to solve. So we get that x is equal to 2. Now keep in mind that we don't want these values. So our excluded value is going to be that x can't equal 2. Try the next one. I don't care about the numerator because we're only talking about where it's undefined. I'm going to take the denominator and I'm going to set it equal to 0 and solve. Now you could do this one of two ways. You could factor with dots, and you get that x is equal to -5 and x is equal to 5. Or you can just solve the equation by bringing the 25 over to the other side. Now keep in mind, when you bring the 25 over and you take the square root, a square root means you need a plus or minus. So you end up getting the same answer, and our excluded values are that x can't equal -5 and x can't equal +5. Because they make the denominators equal to 0 when you plug them in. Let's take a look at equations now. Or if you want, you could pause this video and work on your homework. You should be able to do questions 1 through 4 on your homework now. However, questions 3 and 4 involve more complicated factoring for the denominators. The answers will be weird. They're not integers, they're fractions. Let's take a look at an equation though. In this equation, we want to find where it's undefined. So we're going to take the denominator and set it equal to 0. And we get x is equal to -4. This value makes it undefined. That's why usually in questions you see that a little comma and it says x cannot equal -4, because we know that this is an excluded value, because it makes it undefined. Now let's take a look at what happens when you plug it into a calculator. 1 over x plus 4. In y equals the top left, to get a fraction you hit alpha, y equals, and we have 1 over x plus 4. You're going to go to zoom, and you specifically want to hit zoom 6 to make sure our window is back to normal. And you get this weird graph. So let's take a look at what's happening here. on this graph, we have a weird thing happening. You see how the graph actually flattens out along this line? We call this line, give me 1 second. I want to make a line. We call this line an asymptote. And all an asymptote is a barrier that your graph can't cross through. It's like an invisible wall. And the reason why we can't cross through it, look at where this is happening. This is happening at x equals -4, which was our excluded value. So anytime you see an excluded value that makes the denominator undefined, it's most likely going to cause an asymptote on your graph. Now, keep in mind that the graph gets very, very close to it, but I swear to you, it never actually touches x equals -4. You can even go to your table, and at -4, you'll see that there's an error. Only at -4, because that creates the undefined value. So you can copy your notes. An asymptote is a line of function approaches but never actually touches. They are sometimes caused by excluded values. Keep in mind the line, that green dashed line, is hidden. Let's try the last example. I want to find my excluded values here, where it's undefined. I'm going to ignore the numerator. I'm looking at the denominator and setting it equal to 0. I'm going to use the AM method to factor this. My two numbers that multiply to -24 and add to +2, I believe, are x minus 6. Oh, let's go with the +6. And x minus 4. That seems to work. That means I'm going to have x equals -6, x equals 4. So my excluded values, we don't want x to equal -6 or 4. Now, think about what the graph should look like. You have two excluded values. That's going to create two asymptotes. At x equals -6 and x equals 4. Take a look at that graph. I already put it in the calculator for you. You do have your two asymptotes. We have two weird things happening here. Let's go with a little thinner line. Perfect. And let's draw them. Now, my lines aren't really exact, but there we go. Those asymptotes are happening at -6, and they're happening at x equals 4. And look how the graph gets super close to it, but you're not actually touching it. It just gets close forever and ever and ever. So the asymptote is just a barrier your graph can't actually touch. All right, that's all for this video. You should be able to finish all of that homework now.